Okay, here's what we're going to do now. This is the problem. Basically, we are solving. We're trying out how. Sorry, we are figuring out how to mesh this geometry that we have in front of us. Basically, a rectangle having a oval at the center, which is having a radius of 2.5 millimeters, and the length of the rectangle is 100 mm, and the height is 40 millimeters. I've taken this problem particularly because I don't want to show you something which is very easy to do. I would like to show you something where I probably could encounter a problem, and that way I could also show you how to overcome the problem. So basically this is the problem that I have at hand. I need to show how to solve the meshing part of this problem. In the previous scenario, you seen that in the previous video you have seen that I basically divided this entire region into multiple parts or segments, so to speak. I created one rectangle and then connected them up. So the 1 2 3 4 and 1 2 3 4, the vertically they had practically about 8 segments all in all. I'm going to take a different approach in this particular problem. What I'm going to do here is basically try to divide these into segments like this, one here and another there. Something's wrong with my computer, it's so slow. Anyway, again I'm gonna divide them up like this, right, and divide them up like that. Here, done. They're all going to be perpendicular, of course. So let me move this properly so that it is a proper square now. Okay, once this has been achieved, all I need to do is go ahead and do the remaining part of the solution problem. I just need to connect this and this, right? There's another way of trying to do. I could go ahead and then connect them up like this, or probably like that, right? Which is not going to be giving me a proper result, because I'll show you why. If I connect them up, it's going to be a pentagon. So 1 2 3 4 5, there's going to be 5 edges which I need to be worrying about how to mesh these things. So if I connect them alternatively like this, right, one there and another there, okay, and another here probably, then you can see that it's going to be a much more easier problem to solve, because 1 2 3 4, the only 4 edges that I need to be worrying about. In the same way, I'm going to delete this off and it's not needed anymore. So I'm going to take another one here to here and another one from here to there. Yes, that's going to be help solving the problem. And how many domains have I created? 6 and 8 and 12 domains. Earlier I had 8 domains, now I have 12 domains. 1 2 3 4 5 6 7 8 9 10 11 and 12. I have 12 domains now which I need to be working with. But however, you'll see the advantages of dividing up or segmenting your entire domain into subdomains, into these kind of structures or subdomains, so that even though you have more number of segments, you're going to be ending up with a problem which is much more easier to solve, right? So this is going to be 0 0, obviously 0 and 0, and that has to be say 150 as per our problem before. And if I choose that this length, the length between here to here is, say, okay, this was 2.5. if I choose that this length is, say, 10, okay, and this is also this height from here to here is also 10, and I don't think these are getting recorded here. I'll just put it up like that. Okay, oops, now I guess we better. Okay, from here to here I choose the distance to be 10, and I think we are done with identifying the problems, and I just need to point out the point numbers here. I have point number 1, and I have 2 and 3, 4, okay, and that's 5, 6, 7, 8, 9, 10, 11, 12, so 13, 14, 15, 16, right? So I just need to select them up individually. Don't worry too much about this, it's just PowerPoint. Okay, it's going to be fine. So that's 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go, and the last one, which is 16. Ooh. Anyway, I guess you understood the problem. Now we go back to ANSYS, go to preferences, go to structural, preprocessor. I don't need to do element. Okay, let's choose this as well, element type, solid, and I'm going to go with 4 node as well right now. I don't need real constants for this. Material properties, we can assign it now. Material model, structural, linear elastic isotropic, which is going to be 70. I already explained in the previous video how to select the units which you are working in. So with these are the values which I have taken. Okay, now I'm going to be going back to modeling, and let me start creating the key points. The key points can be created either by using the stuffs on the graphical user interface on the left hand side, which is basically the ANSYS main menu, or I can also use the address bar. In this case, I'm going to be using the address bar as of now. K stands for the key point, and NPT is the number of a point number, which is going to be 0, 1, and I need the first point to be at this place, right? Okay, so I created the first point that I needed, and the second point that I needed is going to be second point. So if this is going to be a 10, let me just bring that down here, and that means that this length has to be how much? So if I take out that's got to be 45. That's 45, and so is this. And in the same way, this has to be 15, and that has to be 15 as well. 15, 15, okay. Oh, okay, this is 50, then that's gotta be 20. Fine, we're done with it. Okay, so we go ahead with creating the second point. This is my second point, so obviously this has to be yeah, you can check the number of points that you have created by using the K list option, which you have already created just now. The second point is going to be at 45. Okay, the third point I can as well choose to ignore this. You'll see what happens in a moment. The third point is going to be 45 plus 10, which is 45 plus 10, so it updates the number on its own, so you don't have to worry about that. And there is another 45. Okay, so we have created basically the first row of stuff, right? So this was the third one, this was the second one, and this was the first one. Where's the first one? This is the first one. Don't need this anymore. So the y point is going to be now offset by a value of 20, right? So I've created the another one. Oops, this has to be 0. I'll just put it back to 0, and this okay, plot. Okay, I think I messed it up. There should be 2 coincident points, so number 5 is also at the center. I'm gonna just delete it off, select, or I can also del k del e, right? K del e, I don't want the point number 1, point number 1, so that's done. I don't need the which point, I don't need the 5th point, right? So 5 and 1, so I've deleted that as well. So I just need to create this now. So k list, I have 4 points, and I can now go ahead and k plot. Yes, I do. Plot controls, go to numbering and key points on, and so on. And then again I go for k 0. I don't want, just leave the decision to ANSYS to update the numbers on itself. Okay, and now it's going to be 0 now, with a value of 20 for the y-axis, and z is 0. Okay, and this has to be 45 now, and this has to be 45 plus 10. See how easy this is, plus 45. This is gonna be plus this whole stuff is gonna be 0. This will be plus 10, right? This will be now 45. This will be 45 plus 10. This is going to be 45 plus 10 plus 45. Okay, so now we go back once again to 0, and that is going to be plus 20 again. Now it's going to be 45 now again, 45 plus 10 and plus 45. Okay, so we have created basically the outline of what we basically need to continue with solving the problem. Now we need to be creating a circle at the center. Before we create the circle, we can just go ahead and create an arbitrary circle to keep arbitrary rectangles to key points, and this, and we can as well go ahead with this, and how about with this one as well, and so with this, here we go again, here we go in, here we go in, here we go in. Done. Go to plot controls, numbering. Let me just check the area numbers. How much we get? A plot. I do have so many stuffs with me. I just need to create this solid circle at the center. Let's go ahead and do that. Arbitrary to circle, solid circle. I need it to be at the center of this. Is going to be, say, 50 and 25 according to the diagram that we have. 50, okay, that is right, and 25 is right as well, and the radius is going to be 2.5. okay, so we've created that. Let me go ahead and just delete what I don't want. Okay, I need to be going to create and operate and in the operate one I'm going to choose booleans and subtract perhaps, yeah, areas, and this is the one and that is the second one. So what did all happen? Okay, something, okay, subtract areas, previous, no, okay, wait, plot controls numbering. I'm going to switch this off so that I can see it properly. Okay, now this is selected, previous, this is selected, okay, yeah, okay, now I've done that. We'll go back to plot, right? Okay, now what I can also do now is a couple of options in front of me right now. I can go ahead and show you on simple stuff which you can also take as another alternative. I'm going to arbitrarily delete this. Now I'm going to show it to you later on. I just don't want to, ruin up my process here. Okay, anyway, let's do something like this. Where is this? Create a line. How would I create a line? Okay, so what do I need to make this? Create key points online with ratio, right? Online with ratio. I'm gonna create this ratio. Online ratio is gonna be 0.5. Apply. Same thing. 0.5, and the same thing again. 0.5. There goes this one, and there goes 0.5, and the first and the final one I'm going to just give okay, right? So create lines now. I'm going to make a straight line from here till here, here to there, here to there, and here to there as well. Okay, now let me see if I can delete these or divide the areas. Yeah, operate, I'm going to subtract, divide, or partition would be better. Partition areas. No, don't want to do it. Just let's leave it as it is. Divide area by line. This is the area that I need. And let's select. Okay, very good. Plot controls and numbering. I'll go to area numbers on. So now if I go to plot and plot areas, or I could as well get just a plot. Now I see multiple areas over there coming up. That's wonderful. Plot controls. Again, I go to numbering, switch this off. Okay, and I don't need this key point numbering as well. I just go back to line plot, which is LPLOT, and enter. You see that if I zoom this here, you have a little orange line and a little green line. They both need to be same. I mean, they need to be added up with each other in order for me to give a seamless mesh. Okay, so what I'm going to do now is basically very simple. I'll just add those two lines up, delete them, apply this one, and I'm clicking the middle mouse button, and last one is okay. So now what do I need to go? I need to go and see plot controls numbering for the final. Before we go to do the meshing, let's just check if there are any overlapping entities or the key points. Okay, there doesn't seem to be any overlapping value or the key points. I just switched it off. Okay, now I go to modeling and meshing, mesh tool. In the mesh tool, I'm going to be selecting some interesting stuff here, which you can note. These are pretty much independent of what I do inside, right? Because they are radially outside from the center of the circle, so it really doesn't matter. and I'm gonna be going ahead with the number of element divisions that I need in this particular case, or even in this the 2.5 say. And should I be needing anything like ratio, different ratio? I don't think I'm gonna be needing it. 2.5. okay, again I probably a mistake. I'm just gonna clear them off. I should have given it in the element edge length instead of the number of element divisions, so I just take it off here and I give 2.5 over this place. Now I have an element edge length of 2.5, so which is beneficial to us, and I could have as well gone to the other ones, but you'll see it's not entirely necessary, so I'm just going to show it to you in a moment. And okay, let me give an example where you could and you need not, right? So this one and this one I'm gonna maintain the same ratios, right? But not for these. Okay, not for that. Okay, now let's go ahead and then concentrate on the inner segment, right? Inner segment, I'm having something like lines, say set. Okay, this one, this one, that one, this one, this one. Okay, now I need to be really creative at this place here. Now I'm gonna be giving say 0.5 perhaps. Okay, 0.5, and give a spacing ratio. I'm gonna use a negative spacing ratio, 0.3. okay, so let's see what happens. Very interesting. So you see that the number of points or the divisions are more towards the center and lesser towards the outer regions. I'm going to flip them up. Okay, I'm going to flip them, or should I be flipping them? No, I don't think so. This is proper. Okay, this is proper. And let me go ahead and set the radial outward lines. Now if I go ahead and do that, it's gonna be how much? Probably an element edge length of 0.75. oops, I kept that same thing again. Here I need to be taking it off. Clear. I don't need the negative spacing ratio here. Set, I'm going to set with only one and then check it out how it's going to work out. 0.75 works out fine, I guess. However, I could still proceed further and be innovative and make the mesh a bit more better. So this one I'm gonna make it like 0. Say something about 7. Okay, 0.7. How is this? Oh, pretty awkward. I guess this is pretty awkward. Okay, anyway. I did a mistake. But it's a mistake. Wait, I need to be going back and clear him off. I will just show you in a moment what is the mistake that I did. I have given the element edge length instead of the number of divisions, so there will be clearly a mismatch between the number of elements that I'm going to have on this arc and the number of elements that I'm going to have on the opposite line, which is a straight line. So you technically cannot get a structured mesh over that place. Yeah, so set this up once again. I'm going to experiment this once again. The number of edges I need, say 10, and I'm going to be making use of a negative ratio again, 0.5. okay, now it seems to be pretty okay. Now I'll set these guys also with the same properties. That's fine. Wonderful. Okay, now what I'm gonna be doing here is set these guys up. Let me just do for one guinea pig, and then we will slowly take this up to other ones as well. So if I make something like 10 divisions on this, or say, okay, I'm gonna go with 10 divisions and an element edge ratio of 0.5, 0.6 maybe. Okay, so clearly this is not proper. I'm gonna take this off, set this to number of elements, say are 6, then go ahead. Now yes, I think it's coming to good shape and good terms, but still there is scope for improvement. Clear this, set this, and I'm gonna increase this ratio a bit more and see, okay, and decrease this ratio a bit more, 0.4 perhaps. Now that seems to be pretty okay and even better. Now we're gonna see how things are gonna be for the other ones. Now this one, this one, this one. So do we need to flip any one of them? Yes, we need to flip this guy up. Now we have pretty much meshed it up. Right now I'm gonna show you how to mesh this quad and mapped. Select this place, select this place, this and this. Now you see how wonderful the mesh looks. We'll go to L-plot once again, and I'm gonna be just showing this, oops, not this one, this one, this and this. Let's see the difference. Absolutely no difference. Or is there a difference? There seems to be a difference. So what is the mistake? So let me just clear these guys, clear this. This is not proper. Obviously you see a distorted mesh. We'll go to L plot. This has not been meshed at all. Such a bomb. Okay, this and this, this not this one. Okay, not that. That is gonna be 2.5 without this, of course. Okay, we'll mesh this. So now you see we have created these guys. Now we need to create the other one. Now set, mesh this. Okay, not bad at all. Now you still see that there is some kind of an elemental distortion here. You can see, I think that's okay. But anyway, if you want it to be perfect, so we can just clear this. And go to L-plot and try. I never really explored this copy actually. Copy line divisions from here to wonderful. Okay, copy from here to all this guys. Done. Mesh this up. Oops, cancel. This guy and this guy. Now we have a perfect mesh, right? Close this. Okay, this seems like a pretty good mesh that we can walk around with. Not bad at all, I must say. There's still scope for improvement though. But anyway, I'll just leave it to you guys to work upon it later on at your own leisure. So this is it. I can wait a second. I can actually show you an improvement that we can still is possible. I'm just going to take these guys off for the moment. This is my L, and this I'm going to set these radial lines, clear these guys up. Okay, and all those parallel guys once again. This one. So basically all the outer rectangles, and simpler to say. Okay, select these guys. These guys here. 2.5. Okay, and probably I go with 5 or 8 even, and with number of element edge length. Okay, no, sorry, number of divisions is 8, and This is going to be very small, 12 perhaps, and spacing ratio of around 0.3. And I'm just going to do for only one, then check it out. Set this one 12. Okay, so what do I need to do? I need to flip this now, right? Okay, I need to flip this. Now that's done, I just need to copy this. So I still have some flipping jobs to do. This needs to be flipped, and this needs to be flipped. This one and this one needs to be flipped as well. Okay, so now I need to be worrying about what I'm gonna do with these guys over this place. So now always remember, the value which I choose for these lines has to be such that the elements that are created at the extreme edges over here, over here and over here are not going to be too skewed or too high an aspect ratio or too low an aspect ratio. Okay, now select this line. I'm just going to try with this. Say, okay, this is probably not going to work out so easily, yes, isn't it? So 12, it has to be more than that, obviously. 20, maybe 0.35. It basically works on your experience, so you don't have to worry about that. Okay, now I'm going to flip this. This element is going to be okay. This element is going to be slightly messed up. So what I'm going to do, I'm going to clear this, set this once again. Okay, probably to 25 elements and 0.4, and flip this. Okay, now I think it's gonna be working fine with that. Set these guys up. Now we need to select, are there any flipping jobs that we need to be doing here? This needs to be flipped up, of course. This, okay. Yes, okay, we'll go ahead and mesh these guys up. Okay, so clearly there has been a mistake here, clear, and I need to flip that. Okay, oh, I have not meshed this. How wonderful. Mesh these guys. Now you see it's even more better. Okay, the elements sort of gradually merge into the center, so as you don't even need, it's hard to see a seam in this particular case. So this is I would regard this as a fairly good mesh. So there it is, an example of how to do a meshing using ANSYS APDL. Hope you enjoyed the video, or hope you liked the video, and hope you learned from the video. Okay, thank you.